Hey students, welcome back. Today we are going to solve the maximum subarray problem. This is one of the very famous interview problems. Let's look at the problem statement first. So the problem statement says we are given an integer array nums and we have to find the subarray with largest sum. We have to find subarray with largest sum and we have to return its sum. We don't have to return the subarray, but we have to return its sum. So we are given an integer array. We have to find a subarray with the largest sum and we have to return the sum. So for example, if we are given this array, okay, the largest subarray that can be found in this array is formed by these elements 4, -1, 2 and 1. Sum of them is 6, hence the output is 6. Now if we are given just a single element, then the sum would also be, maximum sum would also be that element and hence we just return that. Now if we are given these elements, then the maximum sum that can be formed here is the one which is formed by all the elements in the array, which is 23. Hence we return 23 in this case. So let's look at the solution through an example. Let's say we are given this array. First, let's list all the subarrays in this case. So what are the subarrays we have for this array? So 5 is a subarray. 5, 4 is a subarray. 5, 4, -1 are subarrays. 5, 4, -1, 7 is a subarray. 5, 4, -1, 7, 8 is a subarray. Now if we start from 4, 4 is a subarray. 4, -1 is a subarray. 4, -1, 7 is a subarray. 4, -1, 7 and 8 is a subarray. -1 is a subarray. -1, 7 is a subarray. -1, 7 and 8 is a subarray. Then we start at 7, 7, 8 and 8. So these are all the subarrays we have for this. Now what are the sums of these subarrays? So if it is 5, then the sum is just 5. If it is 5 and 4, it is 9. Here it is 8. Here it is 15. Here it is 23. Here it is 4. 3. 3. And here it is 10. Here 18. For this -1, 6. 6 plus 8 is 14. This one is just 7. 7 plus 8 is 15. And this one is 8. So if you observe, the maximum subarray is with this. So we have to find sum of all these subarrays and then figure out find the maximum in it. So then we will find the answer. So while listing subarrays, if you see, there is a pattern here. We are starting at a 0th element and we are matching it with every other element. Once we reach the end of the array, then we are moving this pointer here, which means we are starting at 4 and then we are matching with every other element. Okay. Then we go to -1, we match it with every other element. So like this, we are able to list all the subarrays. So we can follow similar logic in code and list the subarrays. So how will the code look like in this case? Okay. Let's say for int I equal to 0, I less than length of the array. I'm just writing pseudocode I plus. Okay. What we can do is we can keep a running sum at I. Initially it will be 0. We have to keep a running sum because the next sums, we don't have to calculate the subarray sum always. For example, if you know the sum of 5, 4, 5, 4 -1 would be just sum. You adding -1 to the previous sum, which is 9 -1, you'll get 8. Similarly, 8 plus 7, you'll get 15. 15 plus 8, 23. Which is why if you keep a running sum, you can just add to it. So if you don't keep this running sum, then for figuring out the sum, there will be another loop which would become a cubic complexity. Okay. For int j equal to j goes from I. So it goes from I till end of the array. It goes from I till end of the array. Okay. So j goes from I to again length. Okay. J plus plus. What do? We have the sum. So the sum of the latest subarray would be the previous sum plus current element, which would be nums of j. Okay. So the sum of the latest subarray would be previous sum plus the current element. Now we have to keep a track of max as well, right? So for that, let's say we take a variable called max, which we initialize to 0. Okay. Now at every point, what we will do is, after figuring out the sum, if this sum is greater than max sum, okay, if max is less than sum, okay, then we have to update max. Okay, max equal to sum. Now at the end of it, we will have our answer in sum. Okay, so here what we are doing is, we are traversing through the given array once to figure out this starting point of the subarray. Okay, then we are keeping a running sum of the subarray till that point, and we are traversing the rest of the array again, calculating the new sum, and if this new sum is greater than max, we are updating maximum value. Okay, so we have two traversals here, which is why this would be order of n square. Okay, now this is not very optimal, and if you submit this in LeetCode, it will time out for longer inputs. So let's solve this using Kadane's algorithm, which will solve this in order of n time complexity. So we are going to use Kadane's algo. Okay, so first let's try to figure out the sub problems of this. So can we say that sum at I is equal to max of number at I, comma sum at I minus 1 plus number at I. So what we are saying is, the sum at a given point, at this point, would be maximum of its previous sum plus this number, or just this number. So this number basically decides whether I can join the previous sum or am I better on my own. So this is the definition of a sum at a number. Now if we find sum at every point, if we pick the maximum of that is nothing but the maximum sum subarray. Okay, so for this array, let's try to fill the values using this formula. So at 5, sum at 5 is maximum of 5 and sum of I minus 1, which is nothing but 0, plus number of I. So essentially it will just be 5. So at 4, now we have to decide whether we can join the previous batch or I have to create a new batch. So assume that the indices before you are people who know certain number of topics in a subject. Okay, now you know 4 topics and the people before you already know 5 topics. So will you be better off joining them or will you be better off on your own? That is what you have to decide. You can't randomly pick because it is a subarray. It has to be continuous. So you have to depend only on your previous students. So for 4, the previous students are saying they know 5 topics, and at index 1, this guy is saying I know 4 topics. So he will be better off joining them. So it would be 5 plus 4, 9. Okay. So at index 2, this guy is saying -1. I don't know any topics, but I want special coaching in one of the topics. So this guy is saying that, and his previous students already know 9 topics. So he will obviously be better off joining them. So he will join them. Now at 7, this guy knows 7 topics and his previous batch knows 8 topics. So he will also join them. At 8, again, previous batch knows 15 topics, he knows 8. So together they will know 23 if they do a proper combined study. So 23 is the correct answer. So at every point, if we keep a running maximum, okay, we can figure out the maximum. We don't have to store all the array values. If we just keep track of the running maximum, that is enough. Let's look at this through another example. Okay, let's say we are given this array now. So following the same formula, what we will do is, okay, here for -2, it will just be -2 because we are just starting. There are no previous students. For 1, the previous students are saying they have to be taught 2 topics. One is saying I already know 1 topic. So he is not better off joining those students. That is bad company. He already knows 1, so he is better off continuing on his own. So he will start a new batch here. So for 1, using this formula, so it will not be -1 but 1 itself because his value is more than combining with its previous batch. Okay. So similarly for the person at index 2, which is he needs special coaching in 3 topics, which is why it is -3. And his previous students or his neighbors already know 1 topic. So he will be better off joining them. So the result here would be -2. Okay. Again for 4, again his previous students are saying we have to be taught 2 topics, whereas the guy at index 3, he already knows 4 topics. So he is better off on his own, which is why the answer here will be 4. For the person at index 4, he has to be taught 1 topic, -1, and the previous batch knows 4 topics. So he is better off joining them. Similarly, he knows 2 topics, previous batch knows 3. He is better off joining them. He knows 1, previous is 5. Join them. He knows he needs to be taught 5 and there are the previous batch already knows 6, so he will join them. Okay, this guy needs to be taught 4 and the previous batch already knows 1. He will be joining them. Okay, now if you see, of all the sums, the maximum is here. So like in the previous example, maximum need not always be at the end. Maximum sum can come anywhere within the array, which is why we have to keep track of maximum as well. So if we keep track of maximum, we just need the maximum, which is why we don't need any other array or anything to memorize this. We just need to keep track of the maximum. Okay, and we can figure out that this is the solution. In this algorithm, this is very beautiful algorithm. You are only traversing the array once and you are just needing extra 1 element to store the maximum, which is why the time complexity here is order of n, and space complexity, there is no extra memory as such, so order of 1. Okay, so work this out with multiple examples that will give you a clearer understanding. Let's look at the code for this now. Okay, let's switch to LeetCode. So here the first thing we need is we have to keep track of the maximum sum. So initially when we start, let's just say that maximum sum is nothing but sum at element 0, and we also need a running sum, right? The current sum which decides on whether you have to join the previous batch or create your own batch. So that is called current sum. So that also when you start, it is just number at 0, which is when you are starting with just one element, your maximum and current sum are that element. Now you will start with 1 because 0 is already covered, and you will go till length of the array. And what will we do? At every point we will decide whether we can join the previous one or not. Okay, which means you are calculating a new current sum, and you will basically pick the maximum of your value, which is nums of I, and if you join the existing batch. Okay, so if you join the existing batch, will you get more value, or do you have more value on your own? You'll pick that, and based on that, if you pick this, basically you are creating a new batch. If you pick this, you are joining the existing batch. Okay, you'll assign that to the current sum. And similarly, we have to update the max sum as well. Okay, so max at every point we have this current sum holds the subarray sum. So yeah, at every point we have to check if this current sum is greater than max sum. If it is greater, we have to reassign max sum to that value. Okay, return max sum. That's all. So the code as such is very simple, but the algorithm needs some practice to understand. So do try out different array examples and try it out on your own. This algorithm is very important in solving many problems. This problem has also appeared in many interviews. So keep practicing and improve your problem solving skills. Happy coding! If you have any questions, do leave a comment. Please like, share and subscribe. Thank you.